Hello guys, welcome back to Math with Mitchell, and today we're going to be going over how to solve systems of linear equations. Let's get started. So there's two methods into solving a system of linear equations. First is substitution, and then the other one is elimination. I'll show you how to do each of them step by step and sort of how to recognize them. The big key is to understand why we're solving this system and what our answer is. So most of the time, or we can have three different possibilities for answers. One is that we have infinite solutions, which is when you have some number like 3 is equal to 3, where the x's and y's cancel out, and therefore you basically have a true statement, which indicates that these two lines, because they're linear equations, are overlapping. So there's infinite amount of solutions on both of those lines. So there's infinite amount of intersections between the lines, because what you're solving for is the intersection between those two linear equations. And so if they're overlapping, then there's infinite amount of solutions, because there's infinite amount of overlap and infinite amount of intersections. So basically that's one solution type you can get. Another is when you get something that's not true, like 0 equal to 1, and that indicates that your lines are parallel. They never intersect. And so if you have parallel lines, your linear equations are never going to intersect, and therefore you're going to get no solution. And the last one is getting one solution, which is going to be a coordinate point, or it's going to be in the coordinate form x, y, and it could be like x, 0, 1, and that indicates that your line is going to, or your set of linear equations, or your system of linear equations, is going to intersect at this point. So it's going to intersect at that point. So that's basically what you're solving for, is an intersection. And those are, I guess, those are three different ways you can get an output during these methods. So first, let's do substitution. So substitution is personally my favorite, but it's only efficient when you can easily isolate one variable. So see, in this equation, I isolated y. So y is by itself, and the rest of the equation's over here. So that makes it easy, because I have one y over here, and then the rest is over here, where I can just plug in the rest of this equation to y right here and substitute y in the second equation. So then you get 2x plus 2 equals, parentheses is key here. Remember, put parentheses because you're substituting y. So this is y. It's not x, it's 2 plus x. X plus, or minus 5. So let's solve this using algebra. So you get 2x plus 4, because we're in parentheses, equals 3x minus 5. So this is obviously going to give us x. So if we continue to work it out, we get 9. So 9 equals x. So now that we have x, we want to find y. So we'll plug this back into our original y equation. So then when you plug that back in, you get y is equal to 9 plus 2, which equals 11. So then usually you want to write your solution to the equation in points, or a coordinate point, like we have here. So your final answer for the substitution method to solving the system of linear equations is going to be your x value, which is 9, comma 11, because that's your y value. So that's the point in which these two linear equations intersect, and since they're not parallel or overlapping, you get a real answer. Note that you can't quite tell, well, you can tell if they're perpendicular by their slopes, but your solution is not going to tell you if they're parallel just by looking at the solution. So you're going to have to figure out the slopes if you want to figure out that using your system of linear equations. Okay, so elimination, this is the other method to use. This is really handy when you have when you have a system that looks similar to this in that if you multiply it or divide it by a certain factor, you get the same value in the other equation. So I'll walk you through what I mean here. Basically, if you look here at the y's, you note that 2 and 4 are common factors of each other. So if I multiplied this equation by 2, I get 4y plus 6x equals 20. And there's both 4 y's, or there's 4 y's in this equation, 4 y's in that equation. And therefore, we can cancel them out. So the way this works is if you gotta also multiply it by the opposite. So you gotta multiply by the opposite because you want them to cancel out. You want them to eliminate each other. So if I'm trying to eliminate the y's in both equations, I have to have one that's a negative of the equal value, or like -4, and then I need to have an equal to so then I would have to have +4 in the other equation. So that might be confusing, but I will walk you through what I mean here. So I'm actually going to divide the second equation by -2. So if I divide every term by -2, just to keep the number small, then I end up with, this is the new system of linear equations. Then you get -2. Note that y's here are opposite, but they're equal constant, or they're equal coefficients, but the sign is changed. So we have a scenario like this where the 2's can cancel out because one's negative, one positive, and so therefore the y's cancel out. We basically add each column here because they're the same type. So this is all x's, this is all constants, and therefore you get 4x equals 6. And so then you can take the 4 over, and you get x equals 3 over 2. So then, how do we find y? Well, we can substitute x back into any of the equations before, or any of the original equations. I usually like to just choose the first one, or whichever one's simplest. And so I'm going to choose the first one here, but you can plug it back into any, and you should get the same y value. So if you don't get the same y value, then you must have messed up on your algebra somewhere, and I would go back and double check. So I'm going to plug it into the first equation here and get, actually I'm going to plug it into the second equation, our second original equation, because our 2's can cancel out. You'll see why here. So our original equation was 4y minus 2. I'm going to put the x in here, but remember to put it in parentheses always. When you're ever substituting any value, you got to put it in parentheses. Equals 8. And therefore you get 4y, let's just simplify it, minus 3 equals 8. Take the 3 over. You get 4y equals 11. Take the 4 over. And so y equals 11 over 4. That looks like a y. So there we go. So that's how you solve it using elimination. This is also another easy way to do it when the linear equations are in a form easy to manipulate to eliminate each other. So like we did with substitution, your final answer is going to be 3 over 2, because we got to put it in a coordinate point because this is a point of intersection between two lines. 11 over 4 is going to be your y value.